fire tests in Gent. In spring '98, the FVLR carried out a series of fire tests in Gent, Belgium. The building, specially built for large-scale fire tests, is 50 meters long, 20 meters wide and 12 meters high. It's equipped with a sprinkler system, smoke and heat vents aided by ventilation, and smoke curtains. The aim of the tests was to find out whether and to what extent smoke vents and sprinklers influence each other. What course does a fire take without fire prevention equipment? Smoke and toxic gases spread rapidly, thus preventing firefighters from accessing the building immediately. There's great danger to human life. The extreme heats can quickly result in the building being completely destroyed. The graph shows the development of smoke and heat. While during the initial phase of the fire, the temperature rises relatively slowly, large quantities of smoke spread rapidly. The constant rise in temperature finally results in a sudden flashover. In most cases, the building and those inside can no longer be rescued. The series in Gent consisted of 5 tests. The first test was to demonstrate the course of the fire when using sprinklers. In the second test, the RWA system was also opened. The third test was to investigate whether the activation of the RWA had any effect on the sprinklers. The fourth test demonstrated the consequences of a fire where no fire prevention plan was in place. The fifth test shows how the fire spreads if only the RWA is opened and fresh air supplied. In the first test, as in the 2 following tests, approximately 50 kilograms of wood were used to simulate the production of heat and smoke. First, the smoke gathers beneath the 12-meter-high ceiling. The smoke curtain prevents the smoke from spreading into adjacent parts of the building. The steady rise in temperature then sets off the automatic fire extinguishing system. Starting in the area of the fire, the smoke and steam are kept down by the force of the water. The smoke curtain can no longer prevent the spread of smoke. Visibility decreases rapidly. The result of the first test, the activation of the automatic fire extinguishing system prevents the flashover. However, additional smoke and steam are produced and spread downwards, thus decreasing visibility considerably. The second test is carried out with a fire load of 50 kilograms of wood. The smoke and heat vents in the roof open after a short period of time. The smoke is restricted to the area protected by the fire curtain, as the dense smoke can escape from the building. The heat rises quickly, rapidly setting off the sprinkler. In contrast to the first test, in this instance, smoke is not forced down by the water, but safely channeled outside. Ventilation improves the channeling off of increased smoke and steam. In this test, the source of the fire and escape routes remain visible. Results of the second test. The smoke is channeled off through the roof openings at an early stage. This process is aided by ventilation. The activation of the sprinklers results in an increased volume of smoke, but escape routes remain visible. The third test is also carried out with a fire load of 50 kilograms of wood. The sprinkler drums, which set off the sprinkler system, are replaced, and in this instance the RWA is open from the beginning. The aim of this test is to determine whether the fact that the smoke and heat vents are already open affects the automatic fire extinguishing system, and if so, how. The open smoke vents channel toxic gases out of the building, as well as accelerating thermals. The heat is channeled directly towards the sprinklers and sets them off more quickly. The results of this test. RWA and sprinkler do not impede each other. On the contrary, within a fire prevention plan, their combined use can result in the fire being brought under control more quickly. The final two tests investigate the rapid spread of smoke without exposing the test building to extreme heat. The fire load is approximately 30 kilograms of polyethylene. Despite the use of spotlights, the following pictures show the rapid decrease in visibility during a test in which no fire prevention measures were taken.
Rauch ist beim Brand
In the case of a fire, smoke is enemy number one for a human being or a fireman. Even in this hall, with its dimensions of 50 meters length, 20 meters width and 12 meters height, is completely filled with smoke within a few minutes, due to a few kilograms of plastics. Escape routes are no longer visible, and the fireman can only fight the fire source under difficult circumstances. Results of this test: without fire prevention measures, even a large hall is rapidly filled with smoke. The rescue of people and objects inside cannot be guaranteed. For the purpose of comparison, a test is carried out with an identical fire load, but with smoke and heat vents opened and the subsequent aid of ventilation. Intensive ventilation increases the effectiveness of the RWA, thus reducing the density of the smoke as well as the temperature. From outside, it appears that the building is being burnt to the ground. Due to vents on the hall side, the more smoke is channeled out through the roof openings. Inside, visibility is still good lower down. Escape routes remain visible, and in case of emergency, firefighters can access the building quickly and easily. The graph for the fifth test clearly shows that the early elimination of smoke, aided by ventilation, results in good visibility, enabling firefighters to set about extinguishing the fire quickly and effectively. People can be rescued and the temperature of a building minimized within a very short period of time, thus preventing complete destruction. The fire tests in Gent prove that only a combination of fire prevention plans can assure adequate protection of people and objects.